Hello, everyone. Welcome back. Today, we're going to be talking about solving systems of linear equations with infinite solutions. I want to show a few ways of how we can identify when the answer to the solution to a system is infinite solutions. So, I first want to just quickly touch on what would that look like graphically. Basically, um, if we were to graph lines that had an infinite number of solutions, those lines would actually be the same line. They'd be right on top of one another because they would be the same line. Now, they might not look like that on the surface in terms of would the equations look exactly the same? Well, no, maybe not exactly. It might not be super obvious to us at first that that's what it would look like, but that is one way that we could solve a system and figure it out is by graphing both lines and recognizing that, oh, they're actually the exact same line, right? And if they have the same intercepts, then they're the same line, right? Another way we can tell is if we notice here in this case, for example, that we could just multiply this one by 2. We could multiply everything in this equation by 2, and we would get the bottom equation, right? What is 5x times 2? That is going to be 10x. 3y times 2 is 6x, or 6y rather, and 15 times 2 is 30. So notice we multiply everything by 2 in the first equation, we get the second equation. And hopefully that makes it more clear how the equations are the same, right? Because we know that if we multiply any equation by a constant, that we end up with an equivalent expression, right? That's why we're able to do this in elimination, right? Or furthermore, let's say we were to use elimination here and subtract, what would we get? We would get 0 equals to 0. And when is that true, right? What do x and y have to be for 0 equals 0 to be true? Well, there's infinite many possibilities for that x and y could be because 0 equals 0 is always true. There is never going to be a time when this is untrue, right? So that's another way we can think of it, is that if we end up trying to use substitution or elimination and we get an answer that's always true, like 0 equals 0 or 5 equals 5 or negative 300 equals negative 300, therefore the answer must be infinite solutions as well. So those are some ways we can tell. I'm going to give you a second example here though. For this one here, there's a couple ways we could figure this out. Number one, I'm going to show by substitution. Number two, by elimination. And then if you want to, you can try graphing it. And, if you do graph both these equations, then it will be clear that it is infinite solutions because the graph will look the same for both. So let's first use substitution. What if I substitute y equals negative x plus 2 into the equation? I'm going to get into the second equation. I'm going to get 2 times x plus 2 times negative x plus 2 is equal to 4. So that's going to be 2x minus 2x plus 4 is equal to 4. 2x minus 2x is just 0. So we end up with 4 equals to 4. And when is that true? Well, that's always true. So it's got to be infinite solutions. So that's a way we could figure it out by substitution. Now, what about by elimination? Well, in order to do this by elimination, I would have to rearrange the first expression to make it look more like the second expression. If I add x to both sides for the first expression, I get x plus y equals 2. And if I multiply everything in this equation by 2, I get 2x plus 2y equals 4. And then it's very clear that, oh, look, they're the same expression, right? If we just rearrange this first one, we end up with the same as the second equation. And so therefore it must be infinite solutions for that reason as well. Now, of course, we don't have to show all these ways. I just wanted to show a few ways that we could tell that the answer is infinite solutions. Any of these ways, whether you do substitution, elimination, graphing, they're all good, unless you're asked to do it a specific way. Any of those would be valid ways of solving, but those are the things to kind of look for, is look for getting to a point where we don't have any variables anymore. The variables have left us, and we only have something that is always going to be true, like 4 equals 4, for example. All right. Well, that is that one. Good work today, and we'll see you for the next one.